afternoon everyone. In this video demonstrates how to solve question 2 from PSPM KMKT EXCESS 2023/2024 on atomic structure.
Let us look to the question. So question 1. A green laser pointer emits light with a wavelength of 532 nanometer. Determine the frequency of the light. So from this question, we know that the wavelength of the light is 532 nanometer, which is 532 times 10 power negative 9 meter. Then we need to determine the speed of the light. From our syllabus, we know that the speed of the light is constant, which is 3 times 10 power 8 meter per second. So to solve this question, we can use the formula from our syllabus, which is C equal to lambda times nu. From this formula, C is the speed of the light, lambda is the wavelength of the light, and nu is the frequency of the light. So we just substitute all the things into this formula and we can get the final answer of the frequency of the light. Nu is equal to 5.639 times 10 power 14 Hz. So let us proceed to the next question. So from this question, the question tells us to find out the energy of the photon. So to solve this question, we also can use the formula that we learned from our syllabus, which is E equal to H times nu. E is the energy of the photon, H is the Planck constant, which is 6.6256 times 10 power negative 34 joules/second, and nu is the frequency of the light that we find out in the previous question, which is 5.639 times 10 power 14 Hz. So now we also just substitute all things into the formula and we can get the final answer of the energy of the photon. E is equal to 3.736 times 10 power negative 19 joule. So next question. The next question, B. The proton number of the element P and Q are 12 and 17 respectively. Draw the orbital diagram for the valence electron of each element. Suggest the most stable ions for P and Q. Write their respectively electronic configuration. So now we need to determine the question in here. I already highlight the question in here that have 3 questions, which is orbital diagram, most stable ions, and electronic configuration. So now the first we need to find out the electron configuration of each elements. So when we need to find out the electronic configuration, we need to find out the proton number of the element. So from the question, we know that the proton number of P is 12 and the proton number of Q is 17. The proton number is equal to the number of the electron in the element. So now we can write down the electronic configuration for P and Q. For P is 1s2, 2s2, 2p6, and 3s2. And for Q is 1s2, 2s2, 2p6, 3s2, and 3p5. When we write down the electronic configuration, we need to confirm that the number of the electron in the electron configuration is equal to the proton number. So now we can proceed to the next question, which is orbital diagram. Before we draw the orbital diagram, we need to determine the valence electron for each element. So for the P, the valence electron is 2, and for Q, the valence electron is 7. So now we can draw the orbital diagram for P and Q. So now I already draw the orbital diagram for P and Q, and after you draw the orbital diagram, you need to determine that the valence electron in the orbital diagram is equal to the valence electron that I mentioned before. So we can proceed to the last question in this, which is the most stable ion for each element. So for P need to donate 2 electrons from itself and it can achieve the stable electron arrangement. So for P need to donate 2 electrons. So the most stable ion for P is P2 plus. And for Q only need to receive 1 electron from other to achieve the stable electron arrangement. So the most stable ion for Q is Q negative. So the last question. Give the formula when P reacts with Q. State the type of bond formed. So before we solve this question, we need to write down the equation in this question. So the equation when the P react with Q is P2 plus react with 2Q minus, and PQ2 is the final product from the chemical reaction. So we just write down the PQ square as the formula. Then we proceed to the next question, which is state the type of the bond form. So the type of the bond form is ionic bond. This is because there are transfer of electron between the two atoms. Since we know that P donate 2 electron to form P2 plus ion, and Q receive 1 electron and form Q minus electron, there are a transfer of electron between two elements. So ionic bond is formed between the two elements.
Lastly, I would like to give the special thanks to the lecturers from Kelantan Matriculation College for their contributions to the PSPM trial questions. Thank you for watching, and don't forget to subscribe to the PAL KMPK channel for more chemistry solutions and tips. That's all. Thank you.